And we're ready to take notes for 4D in the Math 4 course. Again, Mr. G continues with his series of sine, cosine, and tan jokes. Aren't you glad? All right, here we are picking up the law of cosines. And while it looks like, they're fairly complicated, formulas here, there's something that if you'll notice a pattern, that there's like the cosine of the big angle here at the end. And whatever letter that is, it's the little a that's at the beginning of all of this. And all the rest of this as the other two letters in the same exact pattern each time. So that if I have little b here, I have big B over here. And if I have little c here, I have big C over here. And so that makes it to where you really don't have to memorize the formula but once. And then you just adapt it to the needs of the problem. So let's see how that works. Now, in number 1, they're saying solve the triangle, which means I need to find both angles, and I need to find the one missing side. So, let's start with the missing side. That's probably the easiest. If we mark what we've got, angle C is 20, and little c is what we want, and little b is 5, and little a is 11. And so we're going to, since the only angle we've got is angle C, we're going to have to do it this way. To where cosine C, since we have a C, and then little c is what we're after. So this works out kind of nicely. So when we start plugging this stuff in, we're looking for c squared. A squared is 11 squared plus 5 squared. 2 times 11 times 5. And we already know big C is 20, so that's cosine of C. Now that's something that we can just punch in the calculator all at once if we want, if we felt like it. So we're going to say 11 squared plus 5 squared minus 2 times 11 times 5 times cosine of 20. And that should do it. And that gives us a negative. Wait a minute now. How does that give us? Oh, I punched in something wrong. Let me punch it in right. Okay, punching it in right, I get that c squared is 42.6 something. Now, the thing that gets folks in trouble is that they go to the trouble of punching all of that in and they get the 42 and they say, oh, I'm done. No, you're not. That's c squared. You need to take the square root of this beast. Second square root, second answer. And I get about 6.5. Now, at this point, I can use that to work with the other, and the good news is that I either have to find angle A or angle B with the law of cosines, because once I have two of the angles, I can subtract from 180 for the guy that's missing. So we're going to bring this knowledge that C is 6.5 to this triangle, and we're going to try and solve for, let's say, big A. Now, if we're going to solve for big A, that means our formula is going to look like this. Cosine of big A. Now, when I start plugging stuff in, that's 11 squared equals 5 squared plus 6.5 squared minus 2 times 5 times 6.5 times cosine of A. And so I'm going to have to do everything to get cosine of A by itself so I can get a decimal, and then I can do second cosine and figure out what angle A is. Now, so I've got, and let's expand this out a bit, because let's see, what is 6.5 squared? as 42.25, not be confused with the 42.6 something. We'll let it go. All right, and then 65 would be those put together. Now, when I subtract the 25 and the 42 from 121, I get 53.75 over here. I get negative 65 cosine A over here. So I'm going to want to divide both sides by negative 65. And I get negative 0.8269, yada, yada, as the cosine of A. Now again, well, here you don't have to worry about the ambiguous case, because when I go second cosine, second answer, I put that in, I get that A is 145.78. We'll call it 146. Now, so C was 20, A is 146, little a was 11, little b was 5, and little c was about 6.5. So the only thing that I'm missing now is angle B, which I should be able to subtract. 146 and 20 make 166. Which means that B should be about 14. Yeah. So there's A and there's B. Since A was a rounded answer, that means that B is going to be considered a rounded answer as well. Now, when I plug this in, let's make sure that we don't have any mistakes ready to creep up on us. 146 is the biggest angle. 11 is the biggest side. Check. 14 is the smallest angle. 5 is the smallest side. Check. So we're good. We're good. We have big A is this, little big B is that, and little c is 6.5. All right. Now, let's try it again, only this time we know all three sides. So let's chase after big A first. We're going to say A squared equals B squared plus C squared minus 2BC times cosine of big A. And we're looking for big A here. So when I plug these in, I get 7 squared equals 9 squared plus 5 squared minus 2 times 9 times 5 times cosine of A. Now that's going to be 49 and 81 and 25 and 90. So my first move is going to be to subtract the 81 and the 25 over to the other side, which is going to create a negative number, negative 57 to be exact. Then when I divide both sides by negative 90, interesting, I get 6 and a repeating 3 for a decimal for cosine of A. And when I say second cosine second answer, it gives me that A is about 51. So one down. And of course, all I have to do is do this process again for one of the other angles and then subtract from 180 for the third one. So I really should only have to do this process a second time. So this time let's chase after angle B. It actually doesn't matter which one is which. But let's set up our formula. And then plug in. Let's see, little b, little a, little c. That's going to be 81, 49, 25. That's going to be minus 70 cosine B. By the time I subtract 49 and 25 from 81, I get negative 73. Negative 70 cosine of B. And then I'm going to divide both sides by negative, wait a minute now. No. Sorry, I screwed up something. It is not negative 73. That is 74. Taken away from that gives me 7. And when I divide by negative 70, I get negative 1/10. And when I punch that in, second cosine negative 0.1, I get 95.7, might as well call it 96 degrees. And so at this point, if B is 96 and A is 51, then I add those together. That's, that's 51 plus 96 plus C equals 180. That's going to be 147. That's going to leave me with 33. Now, when I put in the other three sides around, little a is 7, little b is 9, little c is 5, does this actually work? 33 is the smallest angle across from the smallest side, check. 96 is the biggest angle across from the biggest side, check. So we're good. There's B, there's C, and then up here, there was A. Okay. One last problem from the real world is if they're asking us to find the length of segment BC, that is the moral equivalent of little a in this problem. And so we have big A and we're looking for little a. That should direct us toward this for our formula. So let's plug in what we got. We don't know A, we do know B, we do know C, and we do know angle A. Well, I could plug all of that in and have A squared equals some number. Let's see what we got here. So all of that put together should be 41.13 roughly. And when I take the square root, second square root, second answer, it gives me about 6.4. So, I don't know whether these are miles or meters or whatever, but whatever that bridge across the lake is, it's 6.4 units. When little b is 7 and little c is 5. So that is your notes for 4D.